This is 3.5 multi-step equations. Goals are pretty straightforward here. Goal number 1, we want to solve two-step and multi-step equations. And goal 2, we want to make sure we know how to use substitution to check to see if our solution is correct. First, let's do a quick review of one-step equations. Remember, these equations are called one-steps because there's only one operation in the equation. It's either addition, subtraction, multiplication, or division. To solve them, you only have to perform one inverse operation. So here, the first one, I have n plus 3 equals 8. To solve that, I subtract 3 from the left and I subtract 3 from the right, and I get n equals 5. That's my solution. In the second one, n minus 6 equals negative 3. I add 6 to the left, add 6 to the right, and I get n equals 3. In my next one, I have 3n equals 1/2. That's multiplication, so I'm going to divide by 3. Divide by 3. This cancels out. Here, I have 1/2 divided by 3. And I can change that to multiplication, so that would be 1/2 times the reciprocal of 3 is 1/3. And 1/2 times 1/3, I get 1/6. So n equals 1/6. And last here I have division. I have n divided by 2 equals negative 5. To undo that, I would multiply both sides by the denominator. This cancels out. I get n equals, and negative 5 times 2 is a negative 10. So when we talk about two-step and multi-step equations, what we're talking about here are equations where there's more than one operation. So for example, here, I have 2n plus 4 equals 8. Well, the 2n is multiplication, and then I have a plus 4, I have an addition problem. So I have multiplication and addition, two steps. In the second problem, I have n divided by 3 minus 2. I have a division problem and a subtraction problem, two steps. In this problem, 2 times the quantity n plus 3 equals 12, I have 3 steps, so this would be a multi-step equation. First, I have the distributive property. I have to distribute that 2 to the n and the 3, which turns it into 2n plus 6 equals 12. And then I have a multiplication and an addition problem. So if I want to solve these equations, I need to use 2 or more operations. The way we're going to solve these is to use the properties of equality. And one way you can think of it is we're going to do PEMDAS backwards. So we're actually going to start at the bottom of the PEMDAS list. So remember, PEMDAS is our order of operations, rather. And normally we go parentheses, exponents, multiply and divide left to right, add and subtract left to right. But because I have an unknown quantity in my equation, I'm actually going to go backwards. I'm going to first look at my addition and subtraction. So I'm going to undo any addition or subtraction problems first, and then I'm going to undo any multiplication or division problems second. So for example, I have negative 3x plus 5 equals 2. First, I'm going to undo the addition. I'm going to subtract 5 from the left and subtract 5 from the right. That gives me negative 3x equals negative 3. Then I'm going to simplify by using the division property of equality. I'm going to undo the multiplication. I'm going to divide both sides by negative 3. This cancels out, and I get x equals positive 1. Then you do the check. You substitute that 1 back in for x, and you complete the order of operations the correct way, and you should get the same value on both sides of the equal sign. So let me show you one in practice. So I have 2x plus 12 equals 4. So I'm going to do my order of operations backwards. So I have my PEMDAS, right? And I'm actually going to start at the bottom. So I want to look for any addition or subtraction problems to undo. Well, I have a plus 12, so I'm going to do the opposite. So I'm going to subtract 12 from the left, and I'm going to subtract 12 from the right. Well, this cancels out. I bring down the 2x, and here I have a 4 minus 12, which remember is the same thing as 4 plus negative 12. So that's going to be a negative 8. So now I have 2x equals negative 8. My next step is to divide both sides by 2. This cancels out, and I get x equals negative 4. So there's my solution. And then to do the check, I take my original problem, my 2x plus 12 equals 4, and I'm going to substitute that x for negative 4. So I'm going to write 2 parentheses negative 4 plus 12 equals 4. Now I'm going to solve my equation. So I have 2 times negative 4. I have to do the multiplication first because now I'm going to do order of operations the correct way. 2 times negative 4 is a negative 8 plus 12 equals 4, and negative 8 plus 12 is 4. 4 equals 4. My check works. The same concept works when you have division or subtraction. So here I have the problem x divided by 8 minus 1/2 equals negative 7/2. So first, of course, we write the equation, and I have to undo addition or subtraction first. So I have a minus 1/2. So I'm going to add 1/2 to the left, and I'm going to add 1/2 to the right. Well, negative 1/2 and positive 1/2, that cancels out. That leaves me with x divided by 8. And negative 7/2 plus 1/2 equals a negative 3. Then I multiply both sides by 8 to cancel that out and leave me with x. Remember, my goal is to isolate the variable. And then I do 8 times negative 3 is a negative 24. Then you substitute it back in and complete the check. Before I get into a practice one, I want to talk about how we can eliminate fractions from expressions and equations. Now, this is optional, but since many of you are not 100% comfortable with fraction operations, I would strongly suggest you use this process. So, there is a way to eliminate all fractions from an expression or equation. Take a look at this example here. I have n divided by 6 plus 1/3 equals 5. This problem becomes complicated because you have several fractions in there, but there's a way to get rid of all of the fractions. Follow these steps. Step number 1. If you have any mixed numbers, first change those to improper fractions. Step 2. Identify the least common denominator of all of the fractions in the equation or expression. 3. Multiply every term by that least common denominator. So let's go back to the problem here. I have n divided by 6 plus 1/3. My denominators are 3 and 6. Well, the least common denominator of 3 and 6 is 6. So what you're going to do is you're going to multiply that LCD to every term in parentheses. So you're going to put that whole equation in parentheses. Then you're going to use the distributive property and multiply every term by that LCD. Well, 6 times n over 6 is 6n divided by 6. And remember, that cancels out. 6 times 1/3 is 6/3, which simplifies down to 2. And then 6 times 5 is 30. So you've created an equivalent equation. Your equivalent equation is n plus 2 equals 30. Let's look at one more. Remember the steps. 1, if you have any mixed numbers, change those to improper fractions. Identify the LCD, multiply every term by the LCD. So 5n minus 1 3/8 equals negative 1/2. So my denominators are 8 and 2. The LCD is 8. First, I have a mixed number. I want to change negative 1 3/8 to negative 11/8. Then I'm going to use the distributive property, and I'm going to multiply every term by that LCD. I'm going to multiply every term by 8. Well, 8 times 5n is 40n. 8 times negative 11/8 is negative 88/8. And then 8 times negative 1/2 is negative 8 over 2. And when you multiply by that LCD, all the fractions can be simplified. Negative 88/8, it's negative 11. Negative 8 over 2, that's a negative 4. So you've written an equivalent equation, 40n minus 11 equals negative 4. And that problem is a lot easier to solve than 5n minus 1 3/8 equals negative 1/2. So I'm going to do 2 practice problems here. I'm going to do number 4 first. So I have m divided by 2 plus 6 equals 10. Now I do have a fraction here, but I only have 1. So I'm just going to treat that like a division problem, and I'm going to solve this without eliminating the fraction. So I'm going to subtract 6 from the left and subtract 6 from the right. I get m divided by 2 equals 10 minus 6 is 4. Multiply both sides by 2. And I get m equals 8. Now let's do number 6. So I have 2/5 plus 4a equals negative 6/5. This problem looks tricky because I have several fractions here. So if I want to, I can eliminate all of these fractions by multiplying by the LCD of all the denominators of the fractions. So here, my fractions have a denominator of 5 and 5. Well, that's easy. The LCD there is 5. I'm going to multiply every term by that LCD. Well, 5 times 2/5, that's 10/5, which is the same as 2. 5 times 4a is 20a, so that's going to turn into a 20a. And 5 times negative 6/5, that's going to be negative 30/5, which is a negative 6. So now I've turned this problem into 2 plus 20a equals negative 6. And that's going to be an easier problem to solve than my original one of 2/5 plus 4a equals negative 6/5. Sometimes in multi-step equations, you're going to have like terms that are on the same side of the equal sign that you'll have to combine before you solve. So for example, in this problem, I have 3y minus 8y equals 25. 3y and negative 8y are like terms. They can be combined. So remember, 3y minus 8y is the same as 3y plus negative 8y. That's a negative 5y, and I have negative 5y equals 25. I would divide both sides by negative 5, and I would get the solution y equals negative 5.